Alright, so now that we have talked about factoring, we're going to start using factoring for things. And so one of the most obvious choices of things you can use factoring for is solving equations. And what we're going to use here to solve equations is what's known as a zero product principle. It has to do with the rules that deal with multiplying by zero and what that means. And what this says is if you're multiplying two or more things together and you get an answer that's zero, then at least one of them is zero. Maybe all of them are zero, but at least one of them is zero. Now that's the only number you can make that claim for. You can't make that claim for if I multiply two things together and I get 5, then one of them has to be 5, because that's not true. I could take a half times 10 and that would also equal 5. That you'll see that for every other number. But 0 is a special number when it comes to multiplication in that 0 times anything is 0, and that's the only number that has that property. So this is what we call the zero product principle. If you're multiplying two things together, or in other words, if those two things are factors, and the answer is 0, then one of those factors has to be 0. So let's look at some different problems, kind of setups that are going to use this zero product principle. So this is what I might term as like the simplest situation. Everything's already factored for us. We don't have to worry about factoring. It's already equal to 0. So all we have to do is just directly apply this principle. It says if you're multiplying two things together, it's equal to 0. Then either the first thing, x minus 3 is 0, or the second thing, 2x plus 1 is equal to 0. And now we have two linear statements, which we have spent pretty much all semester up to this point solving. So we can solve these, add 3, x equals 3, to solve 2x plus 1 equals 0. Probably first we want to get rid of the coefficient, so subtract 1, or sorry, the constant, and then get rid of the coefficient, divide both sides by 2, and so our answers are 3 and negative 1/2. And we got two answers for this, and that's okay. You're gonna, with the factoring, you're gonna get multiple answers, multiple possible answers. Now, in kind of real world situations, you might get two answers, but maybe one of the answers doesn't make sense. If you're thinking about, I threw a ball in the air and I want to find out when it hits the ground, 3 seconds in the future or a half a second in the past. Well, if I threw it up, it can't hit the ground a half a second in the past. That doesn't make sense. So the 3 might only be the thing that makes sense to me. But at this point, just solving these, it's possible that both of these could be valid answers in situations. Alright, so let's say I want to solve this. So again, I'm factoring. It's already equal to 0, so I need to find out what the factors are. And remember, the way you factor things, first thing you look for is GCF, then you look to see if you can group and see any of those special ones, and then product of binomials. So here, GCF, 2x cubed, 8x squared, minus 24x, all those are even. All of them have at least 1x. So we're going to factor a 2x out. So divide all of those by 2x, and you get x squared minus 4x minus 12 equals 0. And then we're going to factor x squared minus 4x minus 12. So we're going to ask ourselves, what are the factors of 12 that are different by 4? And that's going to be 6 and 2. Set each of those multipliers equal to 0. So I'm going to say 2 could equal 0. What? Wait, what? Well, 2 is a multiplier. This is 2 times x minus 6 times x plus 2. So maybe 2 equals 0. Maybe x equals 0. Maybe x minus 6 equals 0. Or maybe x plus 2 equals 0. Well, I mean, pretty obviously, 2 cannot be 0. That doesn't make sense. 2 is 2, 0, 0. But x can be 0. So you'll see a lot of times if there's just a number factor out front, if it's just like the number 2 or 5 or something, then we don't worry about looking at that as a possible answer, because obviously a number can't be 0 unless that number itself is 0. But if, like in this problem, we might have just said 2x equals 0, and then divided off the coefficient and got x equals 0 directly. But if you have a variable out there as a GCF, one of your answers is going to be 0. And then we're going to solve these other two possibilities. X minus 6 equals 0, so add 6, so x equals 6. Subtract 2, so x could equal negative 2, so my answers are 0, 6, and negative 2. And again, 2 cannot be 0, so that's not one of my answers. So let's look at another problem. Let's look at this problem. All right. The problem here is it's not equal to 0. So I can't use the zero product principle yet. What I need to do is, first thing, get it equal to 0. So I'm going to add that 12 over here to the side with everything else. And I'm going to rewrite this 2x cubed minus 3x squared minus 8x plus 12 equals 0. Now I can factor it, and since it's equal to 0, I can set those factors equal to 0. But now I got 4 terms. How do I factor that? Well, first thing I should look for is a common factor. Nope, not everybody has an x, not everybody's a multiple of 3, not everybody's a multiple of 2, so no. But I do have 4 terms, so I can do grouping. So I'm going to look at the first two. What do those have in common? X squared. So if you take x squared out, you get 2x minus 3. And again, I have to get 2x minus 3 in the second pair. So if I take negative 8x divided by positive 2x, that tells me that I had to factor out a negative 4. And so the common factor here is, don't try to start putting these things equal to 0 yet. It's not done factoring. We're not multiplying yet. We're still subtracting. So a common factor here is 2x minus 3 times the front part's x squared minus 4. Now notice that x squared minus 4 can factor down more. That's the difference of squares. So I should go ahead and factor that. X minus 2, x plus 2, and then the 2x minus 3 that I have. And I'm going to set each of those equal to 0. X minus 2 equals 0, x plus 2 equals 0, and 2x minus 3 equals 0. I put it a little higher because I'm going to need a little bit more space here. And add 2, so one of my answers is 2, subtract 2, one of my answers is negative 2, and then I solve this, add the 3 over, get rid of the constant, and then get rid of the coefficient, divide both sides by 2, and get 3 halves. So my answers are 2, negative 2, and positive 3 halves. And you'll notice on this problem, in the previous problem, the highest power was both x to the third. And you notice on both of them we got 3 answers. On the first problem, if we would have FOILed that side out, we would have gotten x squared, and we had 2 answers for that. That's not a coincidence. Usually, the highest power is how many answers you're expecting. Now, it's possible to get situations where you can't solve them, at least not yet. And so they may not be real solutions that you can find right off the bat. And you might have to take a later course to figure out how to get those other answers. But that should be true, that for a polynomial expression, the highest power, what's called the degree, should be the number of solutions you can find, assuming you can work with numbers that are not real. And like I said, in another course, you'll talk about what is a non-real number. All right, so I get this, and I look at this problem, and I say, this kind of reminds me of the first example we did. You know, everything factored out. So, hey, I'm just going to go with that. 2x plus 3 equals 5, and x plus 3 equals 5. And there's a problem, because I can't use the zero product principle here. I can't use the 5. There's no 5 product principle. This doesn't even make sense for me to try to do this. So, what do? I mean, if it's factored out, but it's not equal to 0, what's going to happen here? And the answer is, and you're not going to want to hear it, but this is what you have to do, and that is, you have to FOIL everything out, bring the 5 over, and refoil it all. So we're going to have to distribute this out. 2x times x, 2x times 3, 3 times x, 3 times 3, and then we're going to have to bring that 5 over, subtract 5 from both sides, and combine those two middle. Don't leave those two middle terms separated, because that isn't not necessarily what we're going to end up working with here. We're going to put those together, and we're going to get 2x squared plus 9x plus 4, and we're going to have to factor this. So, in a way, this is kind of like if you've ever had a situation where someone tried to help you do a job, and then you go and you see that they just did the job entirely wrong, and you have to undo everything they did and redo the job over, and you're like, please stop helping me. Well, that's what happens here. Is it looks like they factored it for you, but in fact, they really didn't help you. They made the problem harder than it needed to be. And so, you have to multiply everything out and start the problem over again. So now we're going to factor this. 2x squared plus 9x plus 4. This, again, GCF, don't have a GCF. Grouping, right now we only have 3 terms on that side of the equation. Special ones, these are not square. I mean, 4 is a square and 9 is a square, but 2x squared is not a square, and that's really what's important here. That end is not a square. So I can't do any of my special ones, not cubes. And so what do? Well, I got to do it the product of binomials, and since that's not a 1x squared at the beginning, I'm going to have to take 2 times 4, that leading coefficient, times the constant. What are the factors of 8 whose sum is 9? And you think about what times what makes 8, but you add them, you get 9. Well, 1 and 8. So we're going to split that 9x up into an 8x and an x. And then we're going to factor that. So we're going to group these. We got 4 terms, pair them up. In the first pair, they both are even, and they both have an x, so we're going to factor out a 2x. And this is, I don't know if we've talked about this situation, though you probably have run across it before in a problem, but you go, okay, this second part has to be an x plus 4, and I have an x plus 4. So I don't need to factor anything out. Well, you do have to factor something out. And normally, what we're going to factor out, I usually say it's a trivial factor. It's not really something all that important. Usually. In this case, it is an important factor. So what do we factor out here? Well, what's positive x divided by positive x? And the answer is positive 1. That's what we're factoring out. Now, the reason why that's important is because when we go to the next step, we need a number to combine with 2x. So 2x plus 1, and then x plus 4. And then we're going to set each of those equal to 0 and solve it like we have been. So subtract the 1 over, divide by 2, you get a half, negative half. And then for the other one, subtract the 4 over, and you'll get negative 4 as your final answer. So that's factoring, using factoring to solve equations. And that is useful for all types of different polynomial expressions solving it. This is the primary method of solving a polynomial expression of power 2 or higher. So what kind of keys you off, like I'm going to have to factor it, is anytime you see you have a power that's x squared or x cubed or x to the fourth or some higher than just x, you're thinking I'm going to have to probably